Alright, we're going to make a probability distribution for problem number 8 on that review that we're working on in class today. Probability of success is 8, or 0.85, and we're going to make this distribution for 9 patients. So the probability that we'll have 0 successes from the therapy out of 9, 1, 2, all the way up to 9 successes out of 9 patients, and we want the probabilities. So we're going to calculate that. We're going to do it because we have this new column here. We don't have to use the sequence command. We can just use our probability command, and it goes like this. nCR 9 comma success, close that, times 0.15 to the 9 minus success. That's sort of taken the place of k, times 0.85 to the k, or successes. So if we do that, and you can see the command right there, if we do that, we should be able to calculate those probabilities. And so how do we get those numbers? So the first one says that less than 3 recover. That would be 2, 1, or 0. And so if we want to see what that is, we can ask it to sum up the probabilities in cell B1 to B3. And if we do that, we get something like that. So 0.00005 if you round to 5 decimal places. So that's the answer to part B. And the answer to part C would be 7 or more. So we want these 3 probabilities. We can do that the same way. Sum, and then B8 colon B10. And so that will give us 0.89, 0.859, or almost 86% will be in that kind of range of recovery. So how do we get, how do we write all that in summation notation for that last part? If we go to a new calculator page, and we get the summation thing up, which is under calculus, and the menu in calculus, K 7 to 9, and then we basically type the command in there that we used before, not with success but with K. So nCR 9 comma K times 0.15 to the 9 minus K times 0.85 to the K. All right, and then that's what it would look like. That's the summation notation form of this. And if you hit enter, notice we get the 0.8591 computation that we got before. So I hope this is helpful in figuring out how to do the problem and make a probability distribution.